All right, good evening, guys. So continuing from last week, we are going to pick up back from basic operations. And you would have by now know what the 4 basic types of operations are. Can anyone tell me what the operations are? Let me call on Miss Scott. Could you tell us what the 4 basic operations are, Miss Scott? Are you there, Miss Scott?
Addition, subtraction, division,
Are those all of them?
and multiplication.
Very good. So, all right, so those are the 4 basic operations, and those are often referred to as arithmetical operation because they have their roots in arithmetic, right? Depends on how you look at the history of mathematics. Some would say that geometry started first and somewhat relate to arithmetic and so on. But if you want, you can do this, the research. But arithmetic basically deals with a lot of calculations and so on with numbers. And so those 4 basic operations are generally what you started off with when you start learning math in arithmetic, all right? Now, we also may extend those 4 basic operations to other operations. So for now, I'm just going to add brackets as an operation. All right, now, as we go along in throughout the course, we are going to be using these operations quite often. All right, but just to review some of these ideas, we talk about the sum being the result obtained by adding 2 numbers. The difference, as we say, we take away the numerically smaller number from the numerically larger one. And product is the result you obtain when you multiply 2 or more numbers together. And we talk about the quotient, one number dividing by the other. So that would be the result you get from dividing one number by the other. And we say that numbers that are added together to give you the sum, we call those what? Anybody remember? So Ojino, remember what we call numbers added together? Are the numbers that we are adding together to get this sum?
We call them adding.
Okay. And so we know that adding plus adding is equal to sum. So for the product, the numbers we multiply together to get the product, we call those what? Anybody? Miss Cummins? Are you calling numbers when that we multiply together to get the
Factors, sir.
we call them factors, right? So generally we say factor times factor equal to product. And quotient now, we know that one number divided by another number. So the number being divided, we call it what? Miss Waysome, remind us. The number being divided, we call it?
Dividend, sir.
And the one that is doing the division, we call
Divide.
the divisor. And it is important that you understand their position in relation to the division symbol because I've often seen students mix up the two, even though they might seem so simple. All right, moving on from there, we want to look at some laws of operation. Did we get to this point last class? Maybe. So we have the commutative law, or sometimes you may say commutative. It depends on what pronunciation you are somewhat take on to. Associative law and distributive law. Can anybody tell us anything about commutative law? All right, let me call on somebody. Hello, Miss Green, how are you?
I'm fine, sir.
Okay. Do you want to tell us something about the commutative law?
No, sir.
Oh, let me see the answer. Those who have gone to the website and did some browsing and reading of whatever was posted there. Nobody? Okay. I know that we are all busy people. And I know we get caught up doing a lot of things, but we have to make sacrifices sometimes to get what we have to get done. Now, it will benefit you a lot more if you are able to read or just look at what is posted there and kind of read ahead of what I'm doing. It makes it easier for you to follow when you do that, all right? So if you are able to, please try and look at the notes before I actually go through them. That will help you a lot more than you coming without any prior knowledge, all right? All right, so commutative law, we're going to look at that one first. And it states, going to ask somebody to read the law for me, what it states. The screen, you want to help us with that?
Yes, sir.
Yeah, go ahead.
Commutative law, the order in which numbers are added and multiplied does not affect their sum or product.
All right. Does that give you any ideas at all of what the commutative law is all about? All right, go ahead, Miss Green. Miss Green, share with us what you understand from what you have just read. All right, Miss Green becomes very shy. Miss Cummins, do you want to take on the task? Go ahead.
Sir, I'm still trying to understand.
Okay, so still not sure what it is saying to you then. What about you, Mr. Ageno? Sorry, Ageno.
Still thinking about it, sir.
Thinking about it. Ms. Waysome, you want to add something to the conversation?
Sure, sir. For example, based on what this is saying, the order in which numbers are added and multiplied does not affect their sum or product. It is saying, or for example, you have 4 times 5, which is equal to 20. You can also say 5 times 4 is 20. It doesn't change the answer. 3 plus 4 is 7. 4 plus 3 would have been the same 7.
All right, thanks, Ms. Waysome. And just to give an example of what Ms. Waysome is saying, this is exactly what it really means. Now, if we look at all of these additions and the multiplication, what you would notice for the addition, we're adding all the same 3 numbers, but in this case, we choose to arrange them so that the order goes from 4, then 6, then 8. Now, if we rearrange them so that we have a different order, 6, then 4, then 8, or even if we try to get another order, 8, then 4, then 6, it doesn't matter which of these order you arrange the numbers in. Once you do the calculation, the answer will be the same for all of the calculation. So same thing goes for multiplication. If you arrange 3, 4, and 6 in that order, then 4 times 3 times 6 in that order, then 6 times 3 times 4, you all will get 72, whichever order you choose to arrange them. Now, what is really important about the commutative law? Can anybody tell me what they think? Why is it important why we are stating this law? What is this law really? Why do we need to understand the law, and how can this law help us? Anybody? All right, Ms. Wilson, I'm going to ask you, since you're the one that give us a better understanding of what is happening.
Repeat the question, sir.
Since the order that we arrange these doesn't matter, how does the law really help us? Or what makes the law so important?
Sir, I'm not sure.
Okay. Anybody would like to try? What do you think? You know, if it is not giving us a different answer, why state it? Why make a note of the law? How can it help us? Go ahead, Ms. Cummings.
Sir, I'm not really sure, but I think it, for example, sir, yeah, if you, the simpler way that you can calculate.
For example?
Sir, what I think is it's not really, it's important because it can give you a way, for example, if you don't know how to do the calculation this way, you can do it in a way that is simpler for you, sir, but you'll get the same answer.
Okay. Anybody else agree with what Ms. Cummings is saying? Ms. Waysome, are you agreeing with what Ms. Cummings is saying? What about you, Ms. Scott? All right. I am in agreement with what she's saying. Now, one of the things that I know back in the days when I was a young lad, before calculators and those things become so popular, when we go down to the little shop where my mother used to somewhat take grocery and credit or buy groceries, what would happen is that the shopkeeper in those days, you carry the list of things that you want from the shop to the shopkeeper, and the shopkeeper go to the list, serve all the items on the list or whatever items that she has, she will serve them. Then now she would put the prices right beside the items. And then now after she does that, she would now add the items in a column form. Now, the thing was, it wasn't the shopkeeper who checked the item alone, because you, the person who's buying, also need to check it to ensure that the shopkeeper calculation and yours are correct, are the same, right? But what the order, the different order of how you can arrange number, how it really helps you is that you may realize that, for instance, in the first ordering of 4, then 6, then 8, you may choose to add 4 and 6, then 8. So if you add 4 plus 6, so you get 10. then 8, you would easily get 18. Now, the second one kind of give you the same working out. 6 plus 4, 10, then 18. Now, if you look at the other one, you would have 8 plus 4, then 6. Now, the last one kind of put your brain through a little different process. So now instead of adding 10 plus 8, now you're adding 12 plus 6. Now, sometimes, depending on how you order the numbers, sometimes it might make the calculation a little harder, depends on how you arrange them. Looking at the multiplication ones now, we see that if you have 3 times 4, you get 12. Then times 6, so you'd say 12 times 6. Or here now we'd have 4 times 3, 12, then 12 times 6. Or you could have 6 times 3, 18 times 4. Now, which of these seem a little easier to do? The 3 times 4 times 6, the 4 times 3 times 6, or the 6 times 3 times 4, if you follow in that order. Anybody? Let's weigh some.
It is a little bit in and out. Can you just repeat for me?
I'm saying now with the multiplications, see which of these order you would likely to calculate easier based on the order.
The first one, sir.
All right. So the first and second one would pretty much probably be easier for some people. What about the third one? Would you find that easier, Miss Green?
No, sir.
Because you would have what? 6, 3, 18. And then 18 times 4. Now, if you're not familiar with 18 times timetable, then that might take a little while to figure out. So you see, by just arranging the numbers in such a way where you can easily calculate them, sometimes your calculation can be hard. All right. So another good thing about the commutative law too is that if you're adding the numbers, you can use one order to add them, and then you use another order to check your addition. So let's say you add 4 plus 6, then 8, and you get an answer, 18. So all right, you say, let me change the order. 8 plus 4 times 6, and you add it from that direction. And if you get in the same answer, then you know that chances are your calculation with the first instant would be correct. Is that clear, guys? Any question about what I'm saying? Raise your hand if you're following what I'm saying and if it is clear to you. What about you, Miss Green? Don't put up your hand if you're not sure now, guys. If you're not sure, what I'm expecting you to do is to say you're not sure and seek clarification. Because what we don't want you to leave getting the wrong idea or leave with an idea that you're not so clear on, right? So wherever you're having doubts, please ask questions so that I can give you clarification. All right, guys. So, all right. So this is what the commutative law is all about. Because the order doesn't matter how you add and multiply things. It means that you can choose whichever way you want to order it so that it can make your calculation easier. All right. Any questions? All right, moving along. Now, this law does not apply to subtraction or division. Can somebody say why? Why it doesn't apply to subtraction or division?
So because it would change the answer.
All right, so when you're subtracting, for instance, if you have two numbers subtracting, so let's say you have 3 take away 1, that would be equal to 1. That be equal to
2.
2. Well, suppose you change the order, then we would have what? 1 take away 3. Now, what would the answer be?
You can't take. Oh, 1 from 3. 1 take away. You can't take. Oh, so
In this case, you are now taking away 3 from 1. So it would not be the same as taking away 1 from 3. It's two different things. So for subtraction, to flip it around and say that we'll get the same answer, that would be incorrect. All right? We can do that for addition. We can do it for multiplication. However, we cannot do it for subtraction nor division. Now for the division, let's say we have 12 divided by 3. We will get what? What we would get if we divide 12 by 3? 3 into 12 goes how many times? Somebody?
4, sir.
4.
4, right. Now, if we should change the order and write 3 divided by 12, would that be the same?
No, sir.
No, because this would give you what? 3 over 12, which would just simplify to what? Anybody?
Auto. 1 over 4.
All right. Do you agree with that? So we are saying then the commutative law or the commutative law, whichever pronunciation you choose, does not apply to subtraction and division. However, it is applicable to addition and multiplication. All right, guys? So we're moving along. Now we're going to be looking at the associative law. But let me ask you first, when you hear the word associative, what comes to your mind? Anybody? Some people will say, well, I am at work with my associates. What that really means?
Being a part of, sir. Like a group or...
Being a part of a group, right? So if we say that, if I ask the question, who are your associates or who you associate yourself with? You're saying what group you really, belong to somewhat. So, if your friends are a little bit different than associate, friends you have a little bit more close and intimate connection with. But your associates are generally people who you associate yourself with or you mingle with, or you could probably say your friends too, because they say that birds of a feather flock together. So when you hear the law, associative law, you should think about groups, right? Now, this is what the law states. Who want to help us now in reading this law for me? Who did the one before? Was it you, Miss Green?
yes, sir.
All right. Can I get a volunteer other than Miss Green, or do I need to call on someone?
Sir,
Go ahead, Miss Cummins.
the way in which numbers are added or multiplied in groups of 2 does not affect their sum or product.
Okay, so that's the law. That's what it states. Now, what can you interpret from what this law is saying? Anybody? What is the law saying, guys? The way in which numbers are added or multiplied in groups of two does not affect their sum or product. Remember, we're talking about groups, and that's what we mean by associative law. Associative law kind of group things together, all right? Group numbers together. All right, let me show you some example and let you figure it out. So look at this example, or these example. Now, can you figure out what it is saying based on these examples? Anybody?
Sir, allow me to try. From my understanding, so basically, I guess if you work whatever in the bracket and then add it to whatever is out, it will still give you the same answer.
Right. How is this law different from the commutative law?
Just the bracket, the grouping.
What that really means?
The bracket, sir. That's the only difference I'm seeing right now. Just the bracket, the grouping of numbers.
You sure that's just the difference, you see? Just that you're grouping numbers.
I guess
In the
so.
commutative law, what happened to the numbers?
Commutative, sir, it doesn't matter in what order you have them. Oh, well, I guess the order remains for doesn't change for the associative.
Exactly. So for the associative law, we are not changing the order of the number, but all we're doing is to group different pairs. That means we're associating them. So the ones that are in the brackets are the ones that are associated. All right, so if we group 3 and 5 together, we're associating 3 and 5. So generally what we would do is work out what is in the brackets first. So for the first one example up here, we see that this bracket 3 plus 5 would give you what? 8 when you work the bracket first, then you add it to the 7, you will get 15. Now, if we choose to associate the 5 and the 7, work out what is in the bracket first, we will get 12. Then we add it to 3, we get 15. Likewise, for the multiplication, in a second, guys. All right, guys, sorry about that. So for the multiplication, we notice the same thing. If we associate the 8 and the 2, multiply those first, then we get 16 times 5, we get 8. And below we have the 2 and the 5 associated first, 2, 5, 10. Then we have 8 times 10, we get 8. Now, how can the associative law help us to make our lives easier? Anybody?
Working out what's in the bracket first, sir.
Working out?
Whatever is in the bracket first.
Well, the associative law. Well, we know in the steps of working out a problem, we always do what is in the bracket first. But for the associative law, it is really saying to you that with the same order, you can choose to form different association. So in the first case, you choose to associate 3 plus 5. So that would become your group, and you work that out to get 8 and then plus 7. The next situation, you choose to associate 5 with 7, that becomes 12, give you 15. Now, just in a similar way like the commutative law, if you choose to associate the right numbers that are easier to calculate, it will make your life easier when you're calculating, especially in the case where you're not using a calculator. All right. Now, most of these laws may not affect students when you're using calculator, but if you're not using a calculator, you will find that it can be very helpful if you understand these laws, because they can help you to make your calculation easier. All right, guys. Any question about what we have done? Now, if you look at the multiplication down here, the first association where I associate 8 times 8 and 2, you get 16. So that 16, now you would have 16 times 5. Now, if you look at the other association with 2 and the 5, now you would have 8 times 10. Now, clearly, if you are good at your timetables, you'll realize that when you multiply by 10, it is much easier than to multiply by 16. Is that clear, guys? Raise your hand if you're understanding what I'm saying. All right, very good. All right, so with that said, we see where the commutative law can help us, and we see where the associative law can help us. So the fact that we are getting the same answer with different association or different order of adding the numbers or multiplying them mean that we can use that to our advantage and manipulate the numbers. Is that clear, guys? All right, moving along now. We're going to look now at the distributive law. Before I put the law there, can you tell me what comes to your mind when you hear the word distributive?